That was a very mean face.
Mom did not give me back my correction tape.
I see.
What?
Mom did not give you back your white out tape stuff. Always. You should just order one of those big old packs of them. Well, that's true too.
Every time I go to Walmart, I forget.
I just order them from the Amazon.
Just like I should get her or ruler.
Shots fired. All right. Turn back to the page that I need. Number 18 begins its life as 5x squared minus 9 equals 11x. And we're supposed to solve this using the quadratic formula. So, what should we do first? Sounds like a great idea. Let's do it. So we're going to minus 11x minus 11x. These ones cancel. And we end up with what on the left side?
5x squared minus 11x minus 9 equals 0.
Does it have to be in that order?
Yes. Has to be in descending order. Well, I mean, it doesn't. Yeah. That's right. So our formula is.
If I did
The opposite of b
minus 9
plus or minus
11x.
square root of 5x
Yes.
squared minus 4.
Well, it depends a little. If the instructions were write this thing in standard form, it would be wrong. If the instructions were solve this using the quadratic formula and you wrote it in the wrong order but still got the correct A, B, and C and got the right answer, then I probably wouldn't count off for that. I would be in the habit of writing in a descending order, but how's it going? Yeah. He is not invisible anymore. You're not doing well? You feeling yucky?
Yes,
Oh,
it's the allergies.
I believe that. Not literally, because he's like 10 feet away from me, so he doesn't literally feel you, but, you know.
Like,
He understands the allergies. Okay, so what's the quadratic formula?
The opposite of b plus or minus square root of ba minus 4ac all over 2a.
Yeah.
It is that, and you do need to memorize it. I've said this before and probably will say it again. What the heck is this notification summary, and how do I kill it? Can I kill it?
Right, what does it look like?
How did they get like only you're not your next? How did they come to that?
How do I kill it?
I can't help you with that.
It doesn't let me kill it. That's
it's there for everyone. I get notifications like that.
stupid Tim Cook. Somebody go push him down a flight of stairs. Safely, of course, because I wouldn't want to actually harm the man. That'd be terrible. That could be interesting. Enough to what?
Enough to scare him.
Yeah, enough to scare him so he'll know to quit doing stupid things. I think I got invited to your play yesterday.
Probably.
I think I did, anyway. Huh?
What'd you get?
I got a text message with, what is the play called? Something about devil worship. No, just kidding. Yeah. Hades Town.
When is that?
And it's in June, right?
Yeah.
I thought it was coming up sooner.
It was intended to be, but the stage we got only had that space open.
Gotcha. Well, it's more likely that I would be able to come in June, so. Okay, so what should I do now, lavender ladies?
See, I have a burn. Okay.
You have a what?
A very bad burn.
Oh, I'm sorry. It may be fine, but it's not fun. Oh, not fun. I'm surprised. I mean, you have such a dark complexion. Yes, it's called sarcasm. Yeah, so I'm not going to put right here.
I just told you 3 times.
Negative 11 sounds like a great idea.
Negative 11.
And then negative 11, and yes, and then 5,
9.
and negative 9,
And then 5.
and then 5. Biggest place for possible mistakes is accidentally not putting those negatives where they belong. That would be the easiest place to make a mistake. So then we just kind of walk through and do the arithmetic, right? Negative 11 is positive 11, right? And plus or minus is still plus or minus, and then we've got the square root of what is negative 11 squared?
121, not 22.
What? 22. That's hilarious. No, because the negative is also squared, remember? That one will never be negative. Never. Because you're always squaring it. So this first part will always end up being positive.
What if you cube something? Will it come out?
It will come out negative, absolutely. Yes, but that's not the point. Well, if you cubed it, it would be negative either way, but yeah.
Wait, if you cubed a positive number, it would be negative?
No, it would no, I'm sorry. That's not what I meant. No. If there was a negative there, like if it was negative 3 cubed, it would be the same as negative 3 cubed. Right. For those following along at home, I was doing hand motions. They understood me. Sort of. Okay. Now, 121 plus
180. Something like that.
Yeah, 180.
it is 180.
Did it from my mind and from this paper.
20 times 9, so
All over 10.
over 10, that's right, equals,
Thank you so much. You have extra square root of 9. It's like hanging off the side.
Why are all y'all so busy?
so then we end up with 11 plus or minus the square root of 201 over 10.
No. Wait. What? Isn't it?
No.
301? Isn't it 301?
No, it's just 3.
It is 301, you are correct,
Thank you.
because arithmetic.
Yeah, because it's the 1 and the 1 and then the 2 and the 8.
Yep.
Where do we get the 100?
That's
301 doesn't have any perfect squares in it,
because it has a 1 at the end.
Well, that's the answer.
so that's the answer.
Does anything with a 1 at the end have a perfect square?
No,
I don't know.
I don't think so. I doubt it.
Probably not, but I don't know.
I mean, it does. It has a square.
I was about to say 21, but no, 21 is not an example. That's a non-example, so no.
It's square.
Probably not.
I mean, it has a square root of 1, but it just makes the same thing. So,
They're not all prime,
yeah.
for sure.
Can we do 16? I don't know what I did wrong.
I don't know what you did wrong either, but I bet we're going to find out. I bet you're going to find out before I finish the problem.
We should actually do like number 20.
You said number what now? Number 16?
81.
16.
The square root of 81 is 9.
True.
Oh, that was true.
So that's the only example, probably.
There's probably, if there's one, then there's an infinite number of them. I'll guarantee you that. I mean, that's kind of how that works. But
What if it was like 99?
now it's probably the smaller version. No, it'd have to be. So it's the smaller version of infinity, not the larger one. But
99 times 99 is 900.
yeah, there are two sizes of infinity. One of them has the size of the set of all real numbers, and the other one has the size of the set of all integers.
So it has 99 times 99.
They're both infinite, but one of them is bigger.
21 also.
Okay. That's some theoretical math of the day. So number 16 was 3x squared minus 4x minus 8.
And 11, which is 121. And 21, which is 441. And 19, which is 3.
Minus 8 equals negative 6.
So I have
Okay, so what now?
No, you add 6 percent.
True. Plus 6, that cancels, leaving us with 3x squared minus 4x minus 2 equals 0. So close and yet so far. Nothing.
so close to you.
Now what?
Now you solve and put into that equation the negative
Now we,
b
yeah, that's right.
plus or minus square root of b squared minus 4ac all over 2a. Something like that.
So we're going to put some numbers in there. Sounds like a grand plan.
4, 3, negative 2, 3.
Did you find it yet? Nope.
Then you
I haven't heard her say, aha.
4 and then 16 and then 24
Over 6.
and then that would be 12 to the square root of 40 over 6.
Why is it plus 24 instead of minus 24?
Because the 2 is negative.
And the 4 is negative, so those cancel.
Did you find it? Did you find the mistake?
Not yet.
Okay. Then it must be in the simplifying radicals phase, probably. Or maybe reducing at the end phase, possibly. We shall see. Square root of 40 over 6.
And that goes to 4 and 10, and then the 4 goes to the 2, so it's 4 plus minus 2 up to the power square root of 10.
I almost wrote 10. I almost made a mistake. So 4 plus or minus 2 times the square root of 10 over 6. And then you need to reduce it, which is probably...
You have to divide them all by 2.
Just kidding. I thought that's where you made a mistake, but I lied.
Divide them all by 2.
Your feeling is accurate.
That's what I did. And that looks right.
Well, that's not often said of me.
That's it?
No, because we got to reduce those. Turn it into 2 plus or minus the square root of 10 over 3. And that's finished.
Do you figure it out?
Yes.
Good. Did you accidentally leave out the 2? That's what I heard.
No, I didn't reduce it.
You,
Oh.
the 4 one.
I reduced
So I was right. It was one of the 2 places I said.
Well, that kind of
I know things sometimes.
gives you a lot of leeway of which
You got a question?
that's why you
Emma Eloise? I see your question face. I can. That's everybody's middle name until proven otherwise. And even sometimes then.
Proven otherwise. Sounds very French.
I like your knife.
You've said that many times.
I know.
I like it too. It's very useful. Did you decide you did or didn't have a question?
Sorry, I just want to be that.
Okay. Okay.
This is black though. That's 2.
Isn't there a square root of 40?
No. There's a perfect square in it. 4.
Okay, I was about to say it's like
But it doesn't come out evenly, no.
No, I bought it at a store for $10. So.
what store?
A trading post. Things there are always marked.
I really want to get a bench made with a S90V blade on it. That would be lovely.
Wow, you just said a bunch of words.
But I can't afford that right now.
It's fine.
Or a Spyderco, even though I don't like their profile as much, I don't like the loop.
I hate it so much.
I don't. They have some that don't have it, but
Almost the only.
their steel is really good.
I love H1 steel because it's practically unrustable, and they're almost the only brand that
Yeah. I don't care about the look. I just don't like it. I think it looks fine, but whatever. Do you have any other questions on your homework?
Is this knife from Kershaw?
Oh.
It's a D2 still, which is great.
I have a leak.
And
It's
that's
great.
the-
It's a great little cheap knife.
It's Kershaw Emerson. A little hook.
No questions on this? No? Not hearing anything else? Okay. So we're going to do lesson 4.6. Is it 2 or 3 at this point? 3, I guess.
What? Wait, we should be. Yeah, we should be 20.
What are we saying?
He wants to do number 20.
Let's do 20.
He got distracted.
Really, really quickly. Yes, I did.
It's too late.
It's too late to turn back. What is your actual question about it, buddy? The domain and range part or the other?
Domain and range part.
So let's just do the domain and range part from number 20. So number 20A basically.
Yeah.
Because that particular topic, if anybody is having a hard time with that, that is one that you will see in the TSI and you will definitely see in a college algebra course. Domain and range. So you do need to understand that topic. Actually, I had a thought this morning. It's a brand new thought, so it's not at all fleshed out. But I had the thought that this morning that after we finish this unit, we might maybe, again, it's brand new thought, so take it with a grain of salt, but we might possibly jump out of this book and look at very specific TSI and college algebra prep.
I'm fine with that.
Because, I mean, we're getting that essentially through this course, but we may dial down and get even more focused at this point on that. Because I think that might be a wise plan. Definitely for those of us who are about to go to college.
No, like me.
Yeah, exactly. And even the ones who have a couple of years, it still would be a good next step, possibly. So we'll see. Okay. So the equation we're working with on number 20 is H equals
Oh, it annoys me so much that.
negative 4.9 t squared plus 3t
Are you a sophomore or junior?
plus 10.
I don't know what the words mean.
That is the real homeschooler answer. Just saying. If you don't say I don't know what grade I am at some point in your homeschool career, were you even homeschooled? That's just the
Words.
That word,
I only know the numbers.
you were homeschooled by a competent teacher.
what?
If you've never said it, you were homeschooled by a competent teacher, which,
That's not quite. That's not even remotely true.
is that really homeschool then?
Well, I don't know. I feel like that's a can of worms. But okay, so for let's see, it's also relevant to look at the words in the problem to think about what the domain and range are. So it says competitors in the 10-meter platform diving competition jump upward and outward before diving into a pool below. The height, h, of a diver in meters above the pool after t seconds can be approximated by the equation this, right? And for A, we want to find the domain and the range of the function. So it's important on this particular problem. This is almost the way it's worded is it's almost a physics problem. You'll see if nobody's in physics right now, right? Assuming you take it, which you may not, potentially, that's possible. But if you do take physics, it depends on whether you take it. Ow, dadgummit. Depending on whether you take it with my wife or with somebody else, it might be in the second or third unit. And you'll see a lot of problems very like this, using velocity or time or height or whatever else. But it's important as we're thinking about domain and range. When we're thinking about domain and range, there's sort of the abstract domain and range, which we talk about a lot. Because what shape is this going to make, first of all?
It's going to make a parabola.
It's going to make a parabola. Is it going to be a parabola opening up or opening down? These are things, yeah, that's great. And these are things that you do need to be able to recognize because without thinking too hard about it. So for anybody that is confused and doesn't want to admit it, how do we know that this is a parabola, first of all?
That's a good question.
What was the question?
How do we know it's a parabola?
T squared.
T squared. Okay, so that's how we know it's a parabola, right? Parabola is this shape or this shape, generally speaking, right? We can have a parabola opening sideways, but we don't usually care about those because they're not even functions. No, I don't think so. What? If you have one opening sideways, then it wouldn't be a function anymore. Remember, because it would fail the vertical line test because it would hit here. Remember when we did that a long time ago? It would touch it twice. It's a relation still. It's just not a function anymore. So we don't usually look at sideways parabolas. They exist. We just don't usually care about them. Which is not denying their existence. Okay. Sorry, I'm cracking myself up over here. It's okay. Don't worry about me. I will be okay, probably. So that's how we know it's a parabola, is because of the squared. How do we know it's opening down?
Because they have to jump down, they can't jump up.
The negative on the...
Okay, so yeah, because the situation says they jump up and then go down, sure. So thinking through the problem, that's a good connection. But you also should, like, if this was just a generic function and it was just y and x and whatever and didn't have the context, you could still tell that it's opening down, right? How can we tell that? Like this one. This is opening down. That's
It's like waves,
what?
It's like water,
No.
Because there's a negative sign.
Because there's a negative on which term? Because this is important. On the squared term. That's right. So since there's a negative on the squared term, that's the answer I was trying to get before we went on all kinds of different fun tangents. It was great. Welcome back. Welcome back, humans. So we know that this is a parabola opening down. Okay, so all of that is things that we need to know. So where I was headed before we kind of reminded ourselves of those things, made sure we were solid on those things. If we have a parabola that's opening down and it's just in the abstract without the problem happening, then what's the domain of this green function here? Is this ever stop getting smaller this way or bigger that way? No. Yeah, so how do we say that in terms of domain?
sideways.
Okay, so yeah, so there's two, okay, yes. So if we're writing things in interval notation, which 9 out of 10 times in a college algebra course, that's how they're going to want you to write it, you're going to do negative infinity to positive infinity. The other conceptual thing that you need to understand is it's all real numbers, right? All real numbers.
Well, isn't that only if it like starts at 0?
No, that's if it goes forever that way and forever that way.
It doesn't go out forever.
Well, we're domain. We're only looking at x, right? I was about to, yeah. So now on the range of this one, it's negative infinity, right, to wherever this is, whatever y this is on this green one, right? I didn't say, I just wrote something generic. Now, so that's for like sort of an abstract problem, which we've looked at a lot, but that doesn't always match the situational domain and range. And this is important to understand the distinction because the domain of this function is all real numbers, but that's not really the domain of the problem. Okay? Does that make sense so far? Kind of, sort of, maybe?
Keep going through the bottom of the pool and keep going.
Well, that'd be the range, but yes. Yeah. So Yeah, so there's two things that we need to understand. One is the range can be as high as they jump, right? So we need to remember how to figure out whatever this is, right? The y part, or in this case the h part, right?
Oh, wow, yeah.
Right? Okay. So that's for the range. The other thing that's important to understand is for the x part, they don't keep on doing this forever, right? So they don't keep on whoever's diving, they're not still diving. They didn't dive and they keep diving, so it doesn't go negative infinity, and they didn't start in the forever infinite back, right? So they do, even though this function has an infinite domain, the situation has a limited one, right? So time in these problems always starts at 0, right? So the domain is going to be 0 to something always on these situations, right? Because we always start at the beginning, and the beginning is 0, right? So we're also going to have to figure this out. We're going to have to figure out the maximum height, which we have a tool to do. I don't know if we're going to remember off the top of our head, but without a little bit of coaxing, we may. But there's also a finite ending. So the domain also is between this number and that number. Okay? Everybody kind of following what I'm saying so far? Don't worry if you're like, how do we do that? It's actually pretty easy for the t part, for the domain part, because it's basically exactly what we've been doing in this lesson. Because all we have to find the domain part is, excuse me, is we have to find the zeros of this function. So when the height is 0. So we've got to put a 0 for h, right? And then solve for t. And we have a handy-dandy way of doing that, hence it being in this lesson, right? So if we've got all that over there and we got that equal to 0, what can we use to solve for t now?
The handy-dandy quadratic formula.
Quadratic formula, that's right. Either the handy-dandy one or the regular one, either one.
The handy-dandy one is more handy and dandy.
Right? So t equals the opposite of b plus or minus the square root of b squared. Yes, you have to memorize this formula. If you were in public school, you wouldn't have to. Because you'd have a formula chart. But you don't take a STAR test, so I get to say, you have to memorize the formula.
Oh, STAR tests were the worst. Oh.
They are long and boring.
Yes, they are. And then you feel like you finish way early.
I would argue that they're more boring for the teachers than they are for the students.
Still.
It's a terrible thing. It's not a very fun thing to do, to wander around aimlessly for 4 hours. Okay.
It's more boring for you, but it's more exhausting for the student.
That's debatable. Okay, so what am I going to put right here? I know.
Then do it.
No, you have to tell me.
It's like the 3 maybe?
Yeah, probably so.
Okay.
And then right here?
And then the negative 4.9. And then the 10 and the negative 4.9. Okay.
Sounded like Jackson so much.
What?
You sounded like Jackson Lucian.
Jackson?
Actually, you
I
sounded
take that as a compliment. So
you sounded like Leah's brother, actually. Oh, yeah.
I feel like y'all are talking about people I don't know. It's okay.
Yeah.
I will make up a story about them in my head. It's fine.
That one time
Jackson's a
Jackson
paramedic
let a warm
and
cry.
has a ballistics vest, and he loves Batman, so. You do that.
And
What is 40 times 4.9?
look it up.
So about
Yeah, look it up.
18 something.
You have a calculator right by your elbow.
I'm trying to do it in the brain. Just
There's no way that 40 times 4.9 is 18 something.
oh, 40.
No way. 196.
I was doing a 40. I was doing the 4 times the 4.9, and then I was able to do 10.
And then 2 times 4.9 is what? That one you could do in your head. Because it'd be 8 plus 1.8.
9.8.
9.8.
Woo! I did it in my brains.
If you would have listened to me, you could have done it faster.
I know.
We sounded
I was
like
kind
the
of
start
thinking.
of one of those documentaries where it's just a bunch of people saying the same word. It cuts from clip to clip.
Oh, yeah, those, yeah. Wow, 205?
If they're really jazzy, they have
So
different languages.
negative 9.8, that's gravity, which, that's really funny, which actually totally this is, of course, duh. I'm sorry. I just had a like a no duh because physics moment, but it's okay.
Is this like a thing in physics, like one of these numbers?
9.8, negative 9.8 technically, because down is considered to be negative in most circumstances, is acceleration due to gravity.
Okay, that's what I was guessing.
So-
I was guessing it was something like that.
There it is. It's acceleration due to gravity. It's how much any object accelerates because of gravity.
With no air.
Assuming nothing else is forcing on it.
Yes. It's
Yeah.
the same thing in different ways.
That's true.
It's fine.
There are a couple things.
So we do want decimal equivalents, right? Because this is a word problem. This is fairly useless in a physics content on words. You get what I'm saying. So what's
There's no.
the square root of 205 equal to approximately?
14.31782.
Calm down, girl. Let's go to like the thousandths place.
That's
Or we could do 41 and 5.
What did you say? 14 point something?
31782.
318.
Yep.
Does that sound right?
Yeah, 78.
Why are we doing it that way then now?
Yeah, but
Or are we doing like 41 and 5 and then doing. Wait, no, that doesn't.
What are you saying? Oh, I did say all that back when you weren't listening. So, anyway, what is negative 3 plus 14.318? Do the math on the top. Negative 3 plus that. Go.
It's like
What did you say?
17.318.
Negative 3 plus what?
17 and then it'll be 11. With the 3.0 all
Oh,
in.
you know.
11, 3.0, and then 17.8.
Yeah. Negative 17, yes, which is important.
Same difference.
Definitely not the same difference.
difference that's the same. Difference.
So when we do those, we end up with negative something, which means that we don't have to care about this one because we don't care about negative time. If that would make an interesting movie for the diver to dive back in time. Time diving? No, it's a terrible name. I don't know. We'll come up with a better name later. Okay. So this is the one that we care about. Did you say starring Adam Sandler? That would be stupid. Adam Driver. Pfft. Overrated. Although much more talented than he appears in Star Wars.
Yeah, that's why.
Same with, what's his face? Edward Cullen guy. What's his name?
He's not wasting his time.
So what's 17.318 divided by 9.8?
Well, it's something like.
Which one?
This one right here.
Wait, I thought you said we didn't care about negative.
We don't care about the one that's going to end up negative, which is this one.
Isn't Adam Sandler the Mythbuster?
That'd be about.
No, it's Adam Savage.
7, 6, 7, 1, 4, 2, 8.
1.6.
No, 7. 1.76. 7.
Okay.
6, 7.
Good. Does it say what time is in this problem? It does, right? Seconds? Yes, maybe.
Yes.
T seconds. Okay. So They're gonna jump up here, and then they're gonna land at 1.76 seconds.
That's a lot. That's like really fast. That's like
So the domain, the range is actually much, much easier to find. We'll look at it here in half a second-ish. Hello, machine.
Hi.
Come back. Baby, come back. Okay, so the domain on this problem, the situational domain, I guess, would be from 0
That's a big.
to 1.76.
That's what I was saying.
Yeah, that diver's zooming.
Well, it makes sense.
Kind of.
They didn't say it was a high dive, did they?
No, but.
Okay.
We all
That's what you're all thinking.
Wow, y'all are all just checking this.
So, what we need to find now, last thing, is we need to find this.
Yes.
That was it.
How can we find that? That's because we got to find the range.
Ask it as nice as you can.
No.
Please tell me.
This, what's another name for the highest point on this parabola? The vertex. So we need to find the vertex. So maybe, just maybe, we should use the vertex formula.
I'm trying to find this, which is in our notes somewhere.
It is in your notes somewhere. And actually, now that you know the quadratic formula, it's probably going to be even easier to remember the vertex formula because it's just a tiny sliver of the quadratic formula.
It's just the opposite of B over probably.
The opposite of B over 2A. That's right.
Oh, I knew that.
So the vertex formula for the x part, right? So it's gonna give us the t part, right? Is just the opposite of b over 2a. Right? So the opposite of b would be negative 3 over 2 times a, which is negative 9.8, right? We already did that over there. So what's negative 3 divided by negative 9.8? Positive something, right? I don't know why I changed to orange instead of green. Sorry for the people who are going to be concerned about it. What?
21.8.
I think you multiplied or something.
306.
It's 3 divided by 9.8.
Oh.
What did you say?
.306.
What did you say? 0.36?
06.
0.06.
0.306.
Yeah, 0.306.
So, at 0.3 of a second is when they reach that height. So now how do we figure out that height now that we know the time? Here we'll go back to green. How's that sound? We're trying to find h. We know the time. Are we here together? How are we going to do that? Kiddos, we got to focus here.
What are you asking?
I'm asking, we know the time. So now how do we find the height? We use the vertex formula to find the time. Put I think we were headed in a good direction there. The time, you mean? Mhm. Up in here. Substitute it up in here and give us the h. So we're finding h of 0.306, right? So we're just plugging it in.
Why did you put 0.306 on that side by the h?
This is showing.
This is function notation,
So if like f of x.
like f of x, h of that. Not h times that, h of that. And the answer to why I did it on this one is to remind you about function notation. That is the why. Which I don't think was really what you were asking, but we answered yours too. So we end up with some number, something approximately equal to 10. That's what it shows in the textbook anyway. So I'm just going to write 10 because I'm not seeing anybody else doing anything, so, you know. So the range is between 0, because it goes down to 0, and approximately 10. Where? I'm writing it right there. That's what I did, just because it went with the other green stuff. It is cool. I agree. Oh, ouch. Yep. Discriminant.
0.6.3.
Yep, because it's part 3, isn't it?
Why are we discriminating?
Because we're like that. It's our privilege. The discriminant is b squared minus 4ac,
Privilege is showing.
which you should recognize where that comes from, right? So, and the reason why the discriminant is important is because if we're just trying to get a basic idea of a graph or a function, we can get it from the discriminant, okay? So, if the discriminant is greater than 0, or or a perfect square, which I don't feel we do list that, but I don't feel like that's necessary, but we'll add it anyway for completeness sake. Because if it's a perfect square, it's also greater than 0. So if that is true, if it's greater, so if the determinant is greater than 0, or it's perfect square, which is redundant, but we'll leave it in there anyway, then the graph or the function has 2 real rational roots.
And then what?
It has. So what does that mean graphically? If a quadratic has 2 real roots, what does the picture do? We were talking about this the other day.
It does.
It's either going to do this or it's going to do this. It doesn't have to be in those places. It could be like, oh, that's the same thing twice.
I was about to say, what's the difference?
There isn't any difference functionally.
Okay.
Or this. It crosses the x-axis twice.
I mean, I was totally willing to accept that it was different, just on different sides.
Yeah, I appreciate your confidence.
Then it was like,
I appreciate your confidence in my ability to not make a mistake. Okay, so if the discriminant, so there are two other cases, of course, which we've already kind of talked about. This is just a way to algebraically discover these. If the discriminant, so b squared minus 4ac, is equal to 0, then the function has one real rational root. Right? So what does that mean graphically?
that the vertex is laying on the x-axis.
Yeah. So something like this one, right? Or something like this one, where it just kisses the x-axis. The vertex is literally on the x-axis.
Oh, so romantic.
So romantic.
When did
That's when discrimination is 0. They're allowed to kiss or something.
when did they get married?
When do they get married?
That's how you know.
Well, that's the next one is marriage or something. I don't know.
When they cross.
I don't know. I feel like the analogy starts to break apart at some point,
If
which is usually true in math analogies, but you know,
if
well, that may be true.
discrimination is 0, so they can kiss.
So if the discriminant is less than 0, what's another name for saying something's less than 0? Negative, right? So if it's less than 0, then it still has two roots, but it has two complex roots. So for our purposes, that means it has an I in it, right? And at this level of mathematics, that's all we really care about with that. It has an I in it, and graphically, what does that mean?
Some real funky stuff.
Not that funky. Not in this context. There are some really cool functions that have complex numbers in them, but not these. What does that mean graphically? It doesn't have any real roots or any real zeros because they're functionally the same.
Remember, this is going to be on YouTube, so don't be too graphic.
That doesn't make any sense in this context, but okay.
You want to know graphically.
Oh, I see. Oh, yeah. Okay. I got it. I didn't get it. I was too slow. It means it's going to be either something like this or something like that. So it never crosses the x-axis.
Yeah.
Does that make sense?
It was too much.
Yeah.
Good.
For this one, they're hugging like this. And they back up. They back up more.
Oh, they're leaving. They're going. One of them's going on vacation.
Leaving on a jet plane.
That was a goodbye kiss.
Don't know when I'll be back again.
It's a hug. Kiss and then goodbye.
Pages 270 through 271. Numbers 22 through 40. No. Oh, yeah, no, we should totally do that.
Whoa, I'm scared now.
22 through 42 evens. That's all she wrote.
One of these days, he really is going to swap it up and make us do odd one day.
And then we have 2 more lessons, and then we have a test. Yay.
Maybe not just.
No, we have to, so that you are comfortable with them. So that your life isn't totally ruined in college.
I don't know.
At least not for that reason, anyway.
I was about to say.
Okay, really quick, remind me how to read corrections.
Okay, so you have to correct all the ones you missed.